Hello everyone, it's just Marcus here. This is my, I think, sixth time trying to record this now, so I'll give it my best shot this time. Um, I'm just going to give you a quick walkthrough of the Geronimo Warrior 2 app. It's basically just a really handy app for helping calculate mass and balance, and not only mass and balance, also takeoff, cruise, climb, and landing performance, and kind of distances, and also stall speed, if you'd like to calculate that. So Geronimo also do weight and balance app for a 172. They do DA-42s, even helicopters. So they do a huge range of aircraft. And today we're going to obviously look at the PA-28 Warrior 2 because that's what we all fly in the group at least. I know other people fly other things, but the app itself is £17.99. 17 dollars 99 cents as well. So if you buy it on the UK App Store, it is, yeah, 17.99. But for how much you get on this app, as you'll see, there's tons to it. It's definitely worth the money. So for setting up the aircraft here, I'll show you all the different screens on the app. It's very simple to use. So you've got a mass and balance screen here, takeoff on the next slide, climb, cruise, and landing, and then at the end there's also a stall speed. So at the very end there's a setup tab, and when you press on save and load, it basically allows you to create an aircraft. But when you press create an aircraft and enter the call sign, Golf Bravo Juliet Charlie Alpha, as you can do like that, press enter. Oh, it's actually done it this time. I've just spent the whole morning trying to create it and it's not worked. But you have to press enter when you type in the call sign, so that's great. So yeah, moving on to this first mass and balance page, as you can see on the top left, there's Golf Bravo Juliet Charlie Alpha loaded. And then this is now an empty aircraft, so on the setup screen, you can have 5 different aircraft loaded. N-Gyro 1 is just the default aircraft that it comes with, and then you can obviously adjust it. But we won't load that as the active aircraft because we want to use Charlie Alpha. So on the left side, you've got all the POB and their weights. You've got the baggage in area 1, which of course is the back, and then you've got the fuel on the bottom. And if you don't want to use pounds, you can, at the bottom right of this page, there's the units changer. So you can use kilograms and litres or pounds and gallons. Might be a bit controversial, but I use pounds and gallons because I don't know why. That's kind of what I learnt whilst flying, and it's what I use at work as well. I used to use at work. So on this bottom, the very bottom right, you've got CG envelope, which of course shows you the mass, center of gravity in the moment, and the of course the envelope where the red cross is, and the yellow outline. And then you've got table view, which is very important. So this is what you need to start with. So looking in the tech log of Charlie Alpha, the most recent Loadmasters certificate for the weight and balance gravity schedule, sorry, weight and center of gravity schedule, the basic weight is reported as 1531. So if you come up here in basic empty weight mass pounds, it's 1531 pounds, and then in the arm inches, they are down as 87.8. So we'll put that in, enter, and it'll update the moment there as 134422. In the tech log, it's down as 134423. So I assume this has been rounded up on the tech log, but that is now all set up for the Charlie Alpha on the app. So this table view also shows you the zero fuel mass, the usable fuel, the ramp mass, and the takeoff mass. Or you can adjust the fuel in gallons for the start, taxi, and run up. So I'm not sure what the actual number is, but I'm going to put 2 gallons just for example if we get an extra long run up. And then yeah, on the left side you've got all the weights of your passengers, etc. So I'll put my weight in. I'm about 12 stone before lunch, which is 168 pounds. And let's say, for example, I'm taking a passenger that is also my size. And you can either use these the sliders, but what's much easier if you press the figure, it will bring you this pad, and I'll just enter £168, which is put that on the top left for pilot, and then passenger one, another £168 person. Which, if you go back to your centre of gravity envelope, it has moved, which of course we've added onto the 1531 basic empty weight. For the baggage, I think worst case scenario, let's say there's 20 kilos of baggage in the back. That's £44 because 1 kilo is 2.2 pounds. So let's say there. And then for the fuel, let's say we're taking full fuel on a flight today, and I'll just base everything off of today's conditions. So, of course, you can slide it up and down. Tabs being, I think, 34 gallons, that's there. Or, as I said with the passengers, you can press on total fuel and you can type in whatever you want. But because we're using full fuel, I'll go with 48 gallons. So that's there. So as we can see, the blue cross on the bottom of this table is the zero fuel mass, and the takeoff mass is the red cross, which at the moment is all very much in limits. So that's all the aircraft weights kind of set up at the moment, and we'll go on to the takeoff performance calculation tab next. So as you can see from the aircraft mass slider, it's updated our weight as we've added it to the mass and balance tab, if that makes sense. So it keeps kind of everything rolling up to date as you go. So moving down, you've got the takeoff elevation, any ISA temperature deviation, and the temperature on the day. The altimeter setting, runway conditions obviously will play a factor, whether you're going on drive pavement or asphalt, sorry, or grass or wet grass, or even long grass and snow. But hopefully we shouldn't be flying in snow. Runway slope, of course, that'll add a factor, and the wind conditions as well. As you can see, a tailwind increases our takeoff distance, and a huge headwind decreases it, as you would kind of expect. And on the right here, you've got the takeoff ground roll and the takeoff distance, and the yellow bar at the top there is our ground roll, and the red bar is the takeoff distance, which of course is taking off 50 foot over the runway to clear an obstacle. And you can even, in the middle of this table on the right, you can choose whether you're taking off with 25 degrees of flaps as a short field, or 0 degrees flaps takeoff. So let's say I'm kind of doing my normal takeoff with 0 degrees, 2 passengers on board, nothing too tasking. You've got big headwind, so not too much to worry about. So I'm going to use just today's weather, which we've got an aero weather here. So it's currently saying the wind is 240 at 20 knots. I probably wouldn't be flying, especially if 24 was closed. But we'll say we're going on runway 20. So we've got our aircraft mass that's updated. Takeoff elevation, it goes up in increments of 100 feet. And because Shoreham's elevation is 7 feet, I'll just leave it at sea level there. And the ISA is, oh sorry, the temperature today is 17 degrees on the ground at Shoreham. So as I slide up and down my temperature bar here, if I move it to 17 degrees here, which is I've just done, it will say it's 2 degrees above ISA, which is correct, and obviously it shows you it in centigrade and Fahrenheit on the end there. And the QNH is 1004 according to AeroWeather, so I can either drag it down or I can enter it by tapping. So I'll just do that, 1004 hectopascals or millibars. If you really want it, it shows you in inches of mercury, but we're not in America, so I won't be using that. So at the moment, that's kind of all up to date. It's a paved drive runway. The runway slope is pretty flat at Shoreham. I don't think there's much kind of percent gradient at all. And then the wing component, we've not updated this, so if we press wing components, this grey button here, it will take you to this page. So it's actually really easy. As you can see, it says tap to rotate. But the wind it's giving at the moment is 240 at 20 knots, so I'll slide it all the way up to 20. There. And then runway heading is 200 is what we're using today. And the wind direction, magnetic. Yeah, it's saying 240, so we can tap here and just enter it 240 there. Or we can tap and drag it, but it's just a bit annoying, so it's much more accurate doing it this way. So wind direction 240, runway heading 200, runway 20 we're using, and wind velocity is 20 knots. So at the bottom left here, you've got wind conditions, it's 15 knot headwind, and the bottom right here, 15 knot headwind, and the crosswind is 13 knots from the right, so getting a little bit close to the crosswind limit, but it's nothing too bad. Depends on what you're comfortable with, obviously. And once we've entered all that information, we can press the yellow button, go back, and it will say down to our right here that the takeoff ground roll is going to be 221 meters or 725 feet, and the total to clear a 50 foot obstacle is going to be 403 meters or 1300 foot. Because of the wind condition, it takes it down. And then the liftoff speed, it says 48 knots. It seems a little bit slow, but that's what the app suggests. But I normally just rotate at 60 knots, so it'll be a little bit longer. And of course, if I was taking off with 20 degrees flat, 25 degrees flaps, it would make it even shorter. So moving on to the next, in fact, before I move on to the next one, the top right here, I almost missed it because it's quite small. There's little images of POH for a ground roll and takeoff performance. So if we press on these books up here, it will show you the actual chart from the POH and the crosses on where what your performance is for the ground roll and for takeoff performance. And of course, if you switch it to 25 degrees flaps, that also gives you the POH pages and your calculations respectively. So moving on to the next page, this is our climb calculation. So it gives you the time, fuel, and distance to climb. So over here we've got a climb start MSL. So of course, again, it's in increments of 100 feet. But because we're at Shoreham, we'll start at 0 feet on sea level pretty much. And let's say we're climbing up to, say, 3,000 feet is kind of what I normally cruise at. The QNH at Shoreham I said was 1004, so I'll enter that again there. And then the altimeter at 3,000 feet, of course I don't know, but let's go with 1004 again. And the OAT I said was 17 at Shoreham on the ground, and let's say the OAT is, for example, 8 degrees at 3,000 feet, which I think is a bit below ISA still, can't remember. But there's also, on the graph above, there's a wind component in the climb, so obviously you can get that from looking at your upper wind charts. So let's say we have a 10 knot headwind in the climb. And at the bottom, there's all our climb figures. So it says it will take us 6 minutes to climb from Shoreham on the ground to 3,000 feet. We'll use about 1 gallon or 4.3 litres, and it will take us just under 7 nautical miles. And it also shows you the pressure, altitude, average climb rate, average climb gradient, and the ground speed if you're interested in that. The POH book for this climb calculation is also at the top right if you want to view it on the original POH page. So that's on there. So it's really easy to use. You basically just, as you'd expect, input the numbers and it will kind of give you your calculations. On the cruise tab, this is the next tab along. So let's say I could be doing a 700 nautical mile flight. As you can see, it's gone red, so that is not available. Let's say I'm just doing a 150 nautical mile flight, and flight level as I said, was 3,000 feet. Power, I normally fly at 2350 RPM. So as you can see on the top right, you've got an RPM gauge, a airspeed indicator, a fuel flow indicator, and a brake horsepower indicator for some reason, if you want to get that deep into it. So moving the power bar up to 2350. There we go. So that's 61% power. And then the altimeter, obviously, as I said, I don't really know, but let's go with 1004 again, for example. And the wind, let's say the wind in the cruise is 10 knot headwind again. And the ISA temperature is, yeah, as you can see on the flight level slider, it's changing, but it was about 7 degrees, so I'll go with that. So it's just a bit below ISA. So on the bottom right, you can see the fuel, the usable fuel is going up and down. For example, if I increase the altitude, my trip fuel goes down, and if I decrease it, my trip fuel goes up. But if we keep it at 3,000 feet, we can see a breakdown on a kind of bar of fuel. So you can see the total fuel that I loaded on the mass and balance page, if we go back to that, is 48 gallons because we took off with full fuel. So the total fuel is all the way to the top because it's full. The trip fuel, which is of course runway to runway, takeoff to landing, is from 10 to 25. So my trip fuel is about 15 gallons, and my reserve, which in a piston aircraft should be 45 minutes minimum, I believe. That's 10 gallons there. But if we press show fuel planning down here, of course we can edit this. So it says at the top here, the total fuel on board is full, 48 gallons. Start up and climb, as I set at the start, was 2 gallons, so about 10 minutes. Climb is going to apparently use 0.1 gallon of fuel, so 6 minutes of fuel. Cruise to land, 12.8. So our trip is, yeah, as I said, about 15 gallons of fuel, or 107 minutes worth. Yeah, the contingency, we can edit that. So if we want, say, 30 minutes contingency, the alternate, let's say we're using Goodwood for an alternate, which is, say, 15 minutes away. And then a final reserve, as I said, in a piston engine's 45 minutes. So that gives us all our reserves in gallons and minutes, and then the total fuel, 27.5 gallons. And it also gives us 48 US gallons available, the max range of 538 nautical miles, miles per gallon, and then litres per 100 kilometres. Of course, all of that 48 gallons is not usable, so you'd have to kind of be aware of that. But that is kind of the breakdown in fuel and the cruise performance. And of course, again in the cruise, you got your POH page if you really want that. I'm not sure if you're able to print these because I just realised that printing these out, if you go foreign or get ramp checked, it would be quite good to provide those. But maybe you can screenshot it and then print it out. And then second to last tab is the landing tab. So if you use the previous tabs as aircraft, say the fuel you've burnt off. So our landing weight is going to be around £2,000. So I'll bring this down to 2022. You can type it in if you like. There we go. Landing innovation, I'm just going to do a shoreham to shoreham, for example, so I'll put 0 again. ISA temperature, it's 17 degrees again. Let's see, there we go, 17 degrees. Altimeter 1004. I'll type that in, a lot easier. And then again, you can put in your runway conditions and wind conditions to get a more accurate landing distance. So it was 240 at 20. Wind direction 240. Let's land on 20 again. There we go. There we go. And the wind conditions, as you can see, it's a 15 knot headwind and a 13 knot crosswind from the right when landing on 20. So if we go back using the yellow button, we can see we've got a ground roll of 110 meters, so quite short, and a landing distance of 225 meters. And at the top, you can see it's a short field landing distance, which is, I suppose, what every normal landing is going to be. So using idle power, flaps 40 degrees, and max braking if you want to land in the shortest distance available. And again, using the books on the top right, you can use ground roll, the page from the POH, that'll show you that, and the landing performance or landing distance page from the POH as well. So as long as you're entering the right numbers, it should be pretty accurate with the weights we added from the tech log at the start. The very final tab is stall speed. So as you can see, as you increase the aircraft mass, the stall speed increases. So in the cruise, let's say it's between takeoff mass and landing mass. So let's say about there, and we've got flaps up. We can see our stalling speed on the left is about 47. Yeah, it even says it at the top of the graph, 47 knots. And if we just basically hit and drag the aircraft on the right, and we choose a bank angle, we can also see that the stall speed increases. So say we want to find the stall speed for a 30-degree turn. On the left there, it says 51 knots and a load factor of 1.2 Gs. This is also shown on the POH book on the top right. We can see it on there too. Of course, if we wanted to see what a stall speed would be with 40 degrees of flaps and a 30-degree turn, it decreases slightly to 45 degrees. Hopefully we won't be stalling at 30 degrees turn with full flaps, but of course you can adjust it all and find out some numbers, and maybe if you want to note them down, that would be a good idea. But yeah, that's pretty much the whole app. If you have any questions, there is a manual online that I'll try and find the link to, but I can also try and provide some answers. So let me know how you get on with the app if you get it, and next time you fly, if you do use the app, maybe note on Sky Demon or the map where you should take off on the runway and see how accurate it is compared to Gyronimo, and then that'll be a real test of how amazing this app is. Because it has worked. I've kind of been 300 meters down the runway and I've taken off at about 300, so it does seem to work. And of course, if you are going to go over the weight, say you have a huge passenger in the back, it will tell you very clearly. There you go, it will say takeoff weight max exceeded, and of course the centre of gravity is out. So yeah, let me know if how you get on, and if you have any questions, and I'll do my best to answer them. I hope that was helpful. So thanks for watching, and I look forward to hearing from you.